Hello friends, I welcome you in lecture number 34 on basic statistics. In this lecture, we will discuss one question on coefficient of correlation which was asked in GTU Winter 2020 exam. In this question, we are asked to compute Karl Pearson's coefficient of correlation between variables x and y for the given data. So here we are given values of x and y and we have to compute Karl Pearson's coefficient of correlation, which we have discussed in earlier lectures. The formula for coefficient of correlation given by Karl Pearson is sigma x minus mean of x times y minus mean of y divided by square root of square of x minus x bar into sigma y minus y bar whole square. So this is the formula which we are going to use to compute Karl Pearson's coefficient of correlation. Here x bar and y bar are mean of x and y, which we can compute by the formula sigma x by n sigma y by n. So first we will find out sigma x sigma y and we will prepare the table, and from the formula we can decide that which columns we will require. So for sigma x and sigma y we will require first two columns as it is x and y. Then we will find out these deviations of x values from x bar, then deviations of y values from y bar. Then we require product of these two deviations. So one column will be x minus x bar times y minus y bar, and here we require square of deviations x minus x bar and square of deviations y minus y bar. So we will require this number of columns in the table, and after finding out all these values we have to put them in this formula and we can easily compute Karl Pearson's coefficient of correlation. And here we can compute the number of values. There are 1, 2, 3, 4, 5, 6 and 7 values for x as well as y. So we will consider n equal to 7. So here we have prepared the table. Here we are written x and y. So under this column we can make the total. Sum of all the x values turns out to be 644. Sum of y values turns out to be 567. So using these two totals we can find out the mean of x and y. Mean of x is x bar equal to sigma x divided by n. Sigma x is 644, n equal to 7. Therefore x bar is 92. Mean for variable y is y bar equal to sum of y values divided by n. Sigma y is 567. So we find that mean for variable y is 81. So once we have x bar and y bar, we can prepare another columns. Here we find out x minus x bar, and mean for x is 92. So we will find out x minus 92. We will subtract 92 from each x value. 100 minus 92 is 8. Then 98 minus 92, 6. 78 minus 92, which is minus 14. Then 85 minus 92 minus 7. 110 minus 92, 18. 93 minus 92 is 1. 80 minus 92 is minus 12. Similarly, we find out this y minus y bar. Y bar is 81. So we subtract 81 from each of these y values and we obtain this column. Then we find out product of these two values, these two deviations, x minus x bar and y minus y bar. So next column is product of all these values. 8 into 4, 32, 6 into 9, 54, minus 14 into minus 11, negative, negative, positive, 154, and so on. We obtain this column which is product of these two deviations, x minus x bar and y minus y bar. Next column is square of deviations of x from x bar, that is we have to square all these values. Square of 8 is 64, square of 6 is 36, square of minus 14 is 196, and similarly we square each of these values and write here. And finally we have to write square of y minus y bar, that is all these values. Square of 4 is 16, square of 9 is 81, square of minus 11 is 121, and so on. We find out square of each y minus y bar, and here we have made the total of these values. Sigma x minus x bar into y minus y bar is 639. Total of square of x minus x bar turns out to be 814. Similarly, sigma y minus y bar square turns out to be 544. So now we have ready-made formula for the Karl Pearson's coefficient of correlation, R equal to sigma x minus x bar y minus y bar divided by square root of sigma x minus x bar square times sigma y minus y bar square. So we substitute all these values from the table. From the table we have sigma x minus x bar times y minus y bar is 639, and these two values are 814 and 544. Sigma x minus x bar square is 814, sigma y minus y bar square is 544. So we substitute all these values, and using scientific calculator we obtain that coefficient of correlation is 0.96. So it is very easy to compute Karl Pearson's coefficient of correlation. We just have to remember this formula for the correlation coefficient, and we can easily compute Karl Pearson's coefficient of correlation.